Hello and welcome to Check's Life Office Hours. It is so great to have you. This is the Stoichiometry Chemistry Office Hours. We have live office hours all week long. You can check that QR code in the top left. If you want to see any of our other office hours, we offer chemistry, calculus, any of those classes in college you can think of. Most of them they have live office hours for. Chegg was so kind as to put these together because they really want their students to succeed. Today, I'm going to be your host. My name is Allison. I go to the University of Louisville. I have TA'd for chemistry and then nursing chemistry for about a year. I've been a student learning assistant for chemistry and then a personal tutor for organic chemistry. I also have some experience tutoring in calculus. But I love teaching chemistry, and tonight I really want this session to be for you guys. So if you have any questions, this could be questions from your homework, questions that you went over in class that you weren't quite sure of, anything in the realm of chemistry that you have a question about, I will do my best to answer. I encourage you to type those questions in the chat from wherever you're streaming, so that way I can answer them and see them. And I also, throughout the live stream, am going to encourage you to participate. So if I ask a question, I might say, try to beat me to solving it. So if I say that, try to type your answer before I say the answer. Or I might ask what we should do for the next step. So if you know what we're going to do to solve the rest of the problem, type that in the chat. That way, we all can make sure we're learning or understanding what's going on so that we know that we can do good on the tests or exams or whatever comes for us. So I encourage you to just actively participate and ask your own questions, and we will get started. I've started with some warm-up questions. These might seem a little bit easy, but I promise we're going to get to some harder stuff. So I always like to start with just a solid stoichiometry problem to get us in the stoichiometry mindset. We want to convert 724,861 milligrams to hectograms. I know most of the weeks I focused on asking y'all about milligrams, grams, and kilograms, but I wanted to add in hectograms to kind of challenge y'all a little bit and see if y'all memorized that. I'd be super impressed. Hectograms don't normally get touched on. But if you know the conversion from grams to hectograms, now is a great time to leave that in the chat. But we are going to get started. And if you can solve this problem before me, also let me know in the chat if you can get that answer before I do. So if you're new here, I always start with something called the factor label method when solving stoichiometry problems. Basically, this is just the way I go about doing the math. It makes it easiest for me, and I'll do a quick little roundup about how I use this. So I start with what I'm given, and in this case, I'm given 724,861 milligrams. So I put that in the top left. Then I'm going to draw a little line. This is going to look like a train track, kind of. But then I draw a line across, see if I can get that straight. And then I'm going to get a conversion that will get me closer to hectograms. I don't know about you, but off the top of my head, I don't know the conversion from milligrams to hectograms. But what I always like to do is go to a base unit. If you don't know what a base unit is, if you've never heard that terminology, base units are grams, liters, anything like that that doesn't have that prefix before it, like milli or hecto or kilo. So I would first go to grams because grams is our base unit. That's what the G stands for. So I put mgs at the bottom. The reason I put this as at the bottom is if I want to cancel out a unit on the top that's not going to be in my final answer, I have to put it on the bottom. Kind of think of fractions in algebra, how you would cancel out that. Something on the top cancels out something on the bottom. So we put milligrams on the bottom, and then we grams on the top because we know that conversion. If you know the grams to milligrams conversion, now's the time. Put that in the chat. But now, how can we get from grams to hectograms? And to do that, it's pretty straightforward. It's just a grams to hectograms conversion. And then because we have grams on the top, we can cancel out grams on the bottom. And we're left with hectograms, which this should match with what you want to end with right here. So we know that that matches. And so we are good. We're now fine to start filling in those numbers. So if you know any of them, this is your last chance. Type them in the chat. But basically, I think back, I have these memorized. I recommend you memorizing them. Most teachers require it, I think, and it's just a good skill to have, especially if your major is chemical engineering like me, or chemistry, or biology, anything like that. It'll be very important to have these memorized. So I know 1 gram has 1,000 milligrams, and I know 1 hectogram has 100 grams. All right. So now that we have all these numbers wrote down, we actually have to solve. The reason I like this method so much is it's super easy. You multiply across the top and you divide by everything on the bottom. So what I would put in my calculator is 724,861 over 1,000 times 100. I would put this straight into my calculator, and that's going to give you my answer. I'm going to give you all about 30 seconds to plug that in your calculator and let me know what you get, okay? About 30 seconds. We can all plug it in together. All right, about 10 more seconds, guys. 5, 4, 3, 2, 1. If you said 7.24861 hectograms, don't forget those units. I know lots of teachers who will count off for not including units. If this was your answer, you're absolutely correct. Great job. And hopefully that was a good thing to get us warmed up so that we can solve the rest of these stoichiometry problems. If you're just now joining, it is so great to have you. I'm Allison. I'm your hostess for the night. And we are doing stoichiometry and chemistry questions throughout this live stream. Again, I encourage you ask any questions that you have. That's what I'm here for. I want to help you better learn. So any questions about chemistry, questions from homework, things you went over in class, type those questions in the chat, and I'd be more than happy to go over them with you. So now we're going to move on to our second problem. What is the limiting reactant if I start with 10 grams of each reactant? If you know what a limiting reactant is, now's the time. Type that in the chat. If you're streaming from YouTube or TikTok, if you know what a limiting reactant is, let me know. Before we get into exactly what a limiting reactant is, whenever we solve any problem, we have to first balance the chemical equation. I wanted to challenge you guys a little bit with this problem. And so I didn't give you the full equation. So we have to figure out what the equation is. This is actually called a double place replacement reaction, which means everything's going to kind of flip-flop. So the cation of one is going to go with the anion of the other. So this is, I'll circle the cations in pink, cation, cation, and then the anion of one is going to go with the cation of the other. So we have that. So basically we're just going to flip-flop. That's going to go with that, and that's going to go with that, and then we just write it out. Your cation always goes before your anion. This is just some simple reaction questions that you might get on a test. If we're not familiar with these questions, I think normally most teachers go over it early in the chemistry course. But if we're not familiar with these types of questions, type that in the chat and I would love to go over these in more detail. There's so many different reactions and there's so much we could learn if that is something that we want to focus on tonight. But so I would switch them. I have K with Cl, so KCl plus AgNO3, and then I just need to balance them. This should be a pretty one, easy to balance because it's a double replacement. So I check. I have 1 Ag over here, 1 Ag over there, 1 Cl, 1 Cl, 1 K, 1 K, 1 N, 1 N, 3 Os, 3 Os. Mine is already balanced. I just needed that one coefficient on each of them. So it's already balanced and it's ready for me to solve my limiting reactant problem. Okay, so if you are unfamiliar with what a limiting reactant is, a limiting reactant is what prevents us from making more product. There's always like 2 or 3 reactants for most chemical equations, and one of them will prevent us from making more product, whereas our excess reactant will have more than enough to make more product. So there's always one that limits our product, limiting reactant, kind of easy to remember. But basically the way that we do this is we start with 10 grams of each is what the problem tells us. So 10 grams of AgCl and 10 grams of KNO3. All right, now we want to go from grams to, let's see if anyone knows. I've been over a few of these in the past few weeks. So I'm going to give y'all 10 seconds. Tell me, what am I going to convert my grams to? 10 seconds. All right, 3, 2, 1. Okay, if you said grams to moles, you're absolutely correct. And that is because we have to convert to moles of our product in the end. And so to get to moles of another product, we have to get to moles of our thing we start with. It's just a rule to convert between different chemical formulas. We have to go to moles first. So we're going to go from grams of AgCl to moles of AgCl. Good job, Enoch. From YouTube, grams to moles is absolutely correct. All right. Now what would we need to finally do to find our limiting reactant? So for limiting reactants, basically the way we find them is we take them to moles of the same product, and whichever makes less moles of that product is the limiting reactant. So I'm going to choose KCl just because it's the first one I see. Oh, I wrote this wrong down here. This should be KNO3 because that's what I started with. That's what you get when you try to do too many things at once, since I was trying to do both of these. But now we're going to go from moles of AgCl to moles of KCl. Moles of KNO3, oops, to moles of KCl. They're both going to moles of KCl. So now our first step we need in these problems is the molar mass. I'm going to give y'all about 30 seconds to find the molar mass of either AgCl or KNO3, and then I'm going to solve them, but I'm going to go through it quickly. So I encourage you, try to beat me to solving this. Find the molar mass of AgCl right here and KNO3. Let me know what you guys get. See if you can beat me. All right, about 15 seconds before I'll start solving. All right, 3, 2, 1. Okay, if you're still in the process of solving and you know what you're doing, maybe mute me for like 1 minute because I'm going to talk and show how to do this while I'm writing it. But if you are a little stuck, this is how we would do it. So we have AgCl, which means 1 mole of Ag and 1 mole of Cl. We need the individual molar masses of both of these. And so what we would have to do is we have to go to the periodic table and find the values. So the number with a lot of decimal points on the periodic table by the element is what your molar mass will be. So for Ag, we have 107.86, and for Cl, we have 35.45. If you found that on the periodic table, the way we find this molar mass is we just add the two. So if I were to put in my calculator 107.86 plus 35.45, I would get 143.31, and that is my molar mass of AgCl. So I'm going to just write that in right here. I think that's what it was. Yep, or actually 0.31. Good job, Enoch from YouTube. That is absolutely correct. There's a few little differences in decibels, but some periodic tables differ in molar mass, so your answer is absolutely correct. Now we're going to do KNO3. So let's look up the molar mass of potassium. Gotta find it on my periodic table. Okay, 39.1. N is 14.01. And O is 16. Now I have 3 moles of O. That's signified by that little 3 right there. So I'd multiply that by 3 and I get 48. Then I'm going to add all of these together. So I add 39.1 plus 14.01 plus 48. And I get 101.11, if that's what you said, for the molar mass of KNO3. You are absolutely correct. So we have 101.11. I'm just going to add a 1 there. And now we need how do we go from moles of AgCl to moles of KCl? Does anyone know what those coefficients would be? What I would put right here in these slots? Does anybody know? I'm going to give you all about 20 seconds. Type in the chat. Let me know what I'm going to put in those boxes. What are my numbers going to be? All right, about 5 more seconds. Okay, there should be a 1 in all of them, and that is because those numbers come from our coefficients in our chemical equation. So since all of these are 1, our coefficients in our stoichiometry are also going to be 1. And now all we have to do is multiply across. So let's multiply that across. And actually, I messed up a little. Y'all got to call me out on my mistakes. So I put this number with the moles instead of the grams, but they should be with the grams because there's not 143 moles in 1 gram of AgCl, but there is 143 grams. So your bigger number should always be with your grams. That's a nice little way to check yourself. So we would just switch these. Let me switch them real quick. 143.22. And then 101.11. If y'all see a mistake, call me out, and then you'll get a virtual high five. But now let's put that in our calculators. So we're going to divide. We're going to do 10 divided by 143.2. The reason I divided is that's just how my factor label method works. And I get 0.0698 moles. Then for the bottom one, I would do 10 divided by 101.11, and I get 0.0989. So whichever one is larger is my excess reactant, and whichever one is smaller is my limiting reactant. So y'all have got 15 seconds. What is the limiting reactant in this problem? "15 seconds. What's the limiting reactant? Does anyone know?" All right, 3, 2, 1. If you said AgCl, you're absolutely correct. AgCl is the limiting reactant because it creates less KCl. The mole amount is smaller than the 0.989. So AgCl is our limiting reactant since it creates less of our product. If that's making sense, put a thumbs up in the chat. If not, let me know and we can go over more limiting reactant problems. This is the only one I planned on going over tonight, but if we have any questions about it, we can definitely do more. So let me know. If you're just now joining our live stream, it is great to have you. This is the Stoichiometry Live Office Hours. Chegg was so great as to put this on for us. My name's Allison. I'll be your host. I encourage you throughout this live stream, ask any questions that you have. I want to help you learn chemistry and stoichiometry the best that I can. I want to personalize it to you. So any questions you have, ask those, type those in the chat. There's a chance that someone watching this also has the same question. So ask those questions, guys. All right. Next, we are going to do a rate equation problem. We had a lot of questions on this last week, so I wanted to do an ice table problem. It is how much of each substance is present at equilibrium if you start with 1 mole of each, this should say of each reactant, in a 5-liter container. Your K is 0.083. So are we familiar with ice tables? Type in the chat yes if you know what an ice table is. Type no if you don't. So I know how much detail to kind of go over this in. But basically, we label I, C, and E. I stands for initial. Initial is what you start with. So how many moles or the molarity of each project you start with. It's always molarity. That is an important thing because teachers will try to trip you up just like I did in this question, and we'll see after I go through explaining it. C stands for change. So how much is that initial concentration changing? That's what C stands for. We'll represent that with a variable, which we'll also go over. And then E stands for equilibrium. So what is the concentration of those reactants, of those products at equilibrium? That is what E is concerned with. And this is an ICE table. ICE tables go with rate of reactions, rate laws. They're really important in chemistry too. So if you're in chemistry 2 right now, that is definitely probably something you've either learned or you will be learning. But let's get started. So basically we're starting with 1 mole of each in a 5-liter container. I said I tried to trick you. It's because you would think, oh, my initial is just 1 mole of each. But it has to be a molarity. So that's why that 5 liters is included. We have to convert the 1 mole in a 5-liter container to molarity. So just the way that we do that is molarity equals moles over liters. So we just put 1 over 5, 1 mole over 5 liters, and we get 0.2. So our reactants are 0.2 initial moles, if that makes sense. If it doesn't, let me know in the chat from wherever you're streaming from. I'd be happy to go over it in more detail. And then since we just start with 1 mole of each reactant, we can assume our products are 0. So I'd put 0 in these slots right here. Next, I'm going to do my change. For change, basically, it's just the coefficient and then a plus or minus sign and then a variable, which in this case, I'm going to use x as our variable just to represent that change that we're not really sure of yet. So what I'm going to do is, since all these coefficients are 1, we have no coefficients in our equation. This is just going to be minus x, plus x, plus x. If you're wondering, hey, Allison, where did you get the minuses and pluses from? The minuses come from losing reactant to form product, because we start with no product, but our reaction is not going to end with no product. So we have to have that product come from somewhere. And so the way we do that is we take away reactant, and that reactant is going to come together to form our product. And then that plus comes because that product is being formed. So our products have plus x because product is being formed. Our reactants have minus x because reactants are being taken away. And then basically for that E, we're just moving all of these columns down. So 0.2 minus x, 0.2 minus x, x, and x. Now we need to figure out what x is. The way we do that is we set up our rate equation. And so our K equation is always going to be K equals the concentration of reactants over the concentration of products. I'm going to give y'all now about a minute to start solving this and see if you can figure out what X is. Then we're going to come together and we're going to all solve after a minute. But I'm going to give you guys a minute head start. If you can solve it in the minute, I'll be so impressed. Type that answer in the chat as soon as you get it. All right, about 30 seconds, guys. Figure out what X is. 15 seconds. You've got this, guys. If you are having trouble with anything, type that in the chat and I will go over it in excruciatingly painful detail. So let me know if you need help with anything regarding this problem or chemistry or homework in general. All right, 3, 2, 1. So the way that we would set this up is we're going to put K equals 0.2 minus x times 0.2 minus x. Basically, I just plugged in these equilibrium values right there over x times x. So let's simplify that. That was not very neat. I need to write better. Okay, so first we're going to do the FOIL method for the top. So we put 0.2 times 0.2, which is 0.04. And I got that from right there. 0.04 minus 0.2x, which I got from there, minus 0.2x again, plus x squared, because a negative x times a negative x equals a positive x squared over x squared. And then I'm going to set that equal to what we're given in the problem, k equals 0.83. So equals 0.83. And now we're just going to simplify and solve for x. So I'm going to first multiply over that x squared. So 0.04 minus, oops, my bad, guys. Let me fix that real quick. All right, perfect. 0.404 minus 0.4x plus x squared equals 0.83x squared. And so I just multiplied that x squared over, and that's where I got the 0.83x squared from. Now I am going to get everything on one side and set it to equal to 0 on the other. So I subtract x squared. I'm going to add my 0.4x and subtract my 0.04. So I should get negative 0.17x squared plus 0.4x minus 0.04 equals 0. Now, ideas. How am I going to solve for x from here? Y'all have 10 seconds. How am I going to solve for x from here? We've went over this a little bit in other live streams, but let me know, how would I find x? You got 10 seconds. All right, 3, 2, 1. If you said the quadratic formula, you are absolutely correct. So we're going to be using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song, if you need help memorizing it, you hear the song like 3 times, it'll never leave your brain ever again. But now let's plug all those values in. So this is b. With the x is always the b coefficient, with nothing is always the c coefficient, and with x squared is always the a coefficient. So we have negative b, so negative 0.4 plus or minus the square root of 0.4 squared minus 4. A is negative 0.17. C is negative 0.04. All over 2 times a. So let's get to simplifying. So I keep that negative 0.4 the same. 0.4 squared is 0.16 minus, let's put negative 0.4 times 0.17 times 0.04 in the calculator, and we'll get minus 0.00272 all over negative 0.34. And then let's solve for that square root. So we do 0.16 minus 0.00272. We get 0.15728, the square root of that, negative 0.4 plus all over negative 0.34. Then let's find the square root of that value, which is 0.3965. So negative 0.4 plus 0.3965 over negative 0.34 plus or minus. I left out my minus sign. Basically, we're going to want to choose the minus sign. In these ice table problems, you have to choose either the plus or minus. You can't have 2 answers. We're going to choose the minus in this case because we want a final answer. If you think about it, you can't have a negative concentration. So you're going to choose the plus or minus that gives you a positive answer. I choose minus in this case because a negative over a negative will give me a positive. So I'm going to do negative 0.4 minus 0.3965 divided by 0.34. And I will get 2.34 equals x. So I've now solved for x. We've done lots of fun math with the quadratic formula. But if we go back, our question asks us how much of each substance is present at equilibrium. X doesn't tell us how much substance is present. X tells us the change. Now, for our products, the change is equal to our substance, but for reactants, it's not. And actually, I think I told us wrong. Yep. Okay. So you know how it's saying we can't have negative concentrations, but this value we would. So we would choose the plus, and that would still give us a positive X value, which is what we want. So we do 0.3965 minus 0.4. Sorry about that. But again, y'all got to call me out if I mess up. So we do 0.3965 in our calculators minus 0.4 divided by 0.34, and we get 0.0102, which is definitely more like what we should be getting. That's equal to X. Now, back to what I was saying up here. If X equals 0.10102, we plug that in for X to find those concentrations of our reactants. So 0.2 minus 0.0102, let's put that in the calculator. And you should get 0.1898. That's your concentration of CO and H2O. And then your concentration of your products, H2 and CO2, is just that 0.102 there. Hopefully we're all following. If you're not, let me know in the comments of wherever you're streaming from. If you're just now joining, it is so great to have you. My name is Allison. This is the Czech Stoichiometry Live Office Hours. We are about halfway through our live stream, so we don't have much time left for you guys to ask questions. So any questions you have, type those in the chat. I'd be more than happy to answer them. It could be homework help. It could be anything like that, things you went over in class. Let me know so that we can solve them right now. But if nobody has any questions at the moment, start typing them so you can ask them, but we'll move on to the next question. So this one is a gas law question. What is the pressure of H2 if you have 0.142 moles at 284 K in a 4.3 liter container? Does anybody know the gas law? I'm going to give you all 30 seconds. Let me know what the gas law is. What is the equation for the gas law? Got about 15 more seconds. See who can type it in the chat first. What is that equation? 3, 2, 1. If you said PV equals nRT, you are absolutely correct. That's exactly what the gas law is. So we want to find the pressure of H2 if we have 0.142 moles at 284 K in a 4.3 liter container. So what I like to do is first solve the equation for what I'm solving for and then plug in the numbers. This is a really common practice in like chemistry, physics. Most of your teachers will want you to solve for the variable and then plug in the numbers. It helps your math go by a little smoother. So we're going to just solve for pressure. And the way we do that is we just divide both sides by V. And you should get P equals nRT over V. Now, that's our equation to find the pressure. What I find is easiest is next to label all of those numbers with what letter they're representing in the equation. So N stands for moles, which is 0.142 in this case. T stands for temp, which is 284 K. V stands for volume, which is 4.3 liters. And R, does anyone know what R is? This is your challenge question of the night. Who can tell me what R is first? You have 15 seconds. What is the value of R? What is that number that represents it? 10 seconds. What is R, guys? I know you guys know it. 3, 2, 1. If you said 8.314, you are correct. That's the number. And then the units, little trickier to remember. There's actually multiple units and multiple values of R. The one we see in chemistry most is this 8.314 atm per L per mole K. But actually, there's like hundreds of different ways you can write R with different numbers and different units. If you take chemical engineering or any engineering classes, you'll probably see it. But for chemistry and bio, for the most part, it's 8.314 or 0.08314. But now let's just plug in. So we have P equals 0.142 moles times 8.314 atml per mole K times T, which is 284 K, over our volume, which is 4.3 liters. And then we want to cross out the units to make sure they all match and leave us with just a pressure unit. So my K down here will cancel out with my K there. And that's because, again, remember what we talked about earlier. Top cancels out bottom. My mole here will cancel out mole there, and liter there, liter there. So I'm just left with ATM, which is a pressure unit. So that is correct. Now I just have to put this in my calculator. I'm going to give y'all 1 minute. Put it in your calculator. See if you can beat me to solving it. You've got 1 minute. What is the pressure of H2? About 40 seconds. What is that value, guys? See if you can beat me to solving it. All right, about 10 more seconds, guys. What is that value? All right, 3, 2, 1. If you said P was 77.97 ATMs, you are absolutely correct. That is the right answer. Virtual high fives to everyone who got that. Great job. Hopefully that makes sense. If that doesn't make sense, let me know in the chat. I would love to walk through another problem like this or give you an answer in more detail. Again, we have about 20 seconds of our, not 20 seconds, 20 minutes of our live stream left, a little bit more. So any questions you have, ask them now so that I can help you and answer them for you, and that we can get all of our chemistry questions answered tonight. That's what I'm here for. I would love to answer your guys' questions. If you're just now joining us, welcome back. It is so great to see you. If it's your first time, thank you for joining. We have different stoichiometry hours. Well, we have stoichiometry hours every week at this time, but we also have different office hour times like regular chemistry, organic chemistry, calculus, and you can get that schedule in that QR code in the top left. For now, while y'all are typing your questions, we're going to move on to question 5. If you pour 5 milliliters of 8 molar solution into a beaker holding 23 milliliters of water, what is the new concentration? This is a really simple equation that most people tend to forget how to solve or forget the equation in general. And they try to overcomplicate this a lot more than it needs to be overcomplicated. So I'm going to give you all about 20 seconds to think, what is this equation? And then let me know in the chat of wherever you're streaming from, TikTok, YouTube, whatever it is, let me know what that equation is. All right, about 10 more seconds. All right. 3, 2, 1. If y'all see me looking crazy, there's like a gigantic bug in my house. I'm scared of bugs. But anyways, we have we are going to solve this problem. The equation is M1V1 equals M2V2. And that's just our average dilution equation is what you'll see this most of the time referred to. Basically, the molarity of one thing times the volume of it equals the molarity of another times the volume of that. So it's really hard to mess this up unless you just don't put the correct numbers together. But if you do that, this is an easy A on a test. Easy, all the way correct problem. So I just like, for ease of mind, to label what goes together. Basically, if you see the word of, that means those numbers are the M1s and the V1s. Capital M stands for molarity. That's why you see that match. And then V always stands for volume, so milliliters. So for my M1, I would put 8 M. V1 is 5 milliliters equals M2V2. I want to know the new concentration. So my M2 is just going to be X, but my V2 we're given, that's that 23 milliliters of water right here. So I just put in 23 mLs. And then I want to solve for X. So to do that, how would we solve for X? Let's see how good your guys' algebra skills are. 30 seconds. How would we solve for X? All right, 15 seconds, guys. How do we solve for X? Okay, if you said we just divide by 23 on both sides, you're absolutely correct. So you'd put 40 over 23 into the calculator, and that equals X. So we'll go ahead and get a decimal value. If you got 1.74, capital M, so 1.74 molarity equals X, you are correct. Great job. Good job, guys. All right, we're going to keep on going. As a reminder, if you have any questions, type those in the chat. I'd be happy to answer them for you. That is what I'm here for. We don't have to do these last problems I wrote at all. This rest of the session can just be to help you guys and what you personally need help with. So let me know any questions you have. If you need me to explain something in better detail that we've already went over, let me know. And if you're just now joining, thank you so much for joining this live stream. It is great to have you. We are going to now do some rate law questions. I had quite a few questions on this last week, so I definitely wanted to go over it in a little bit in more detail about rate laws and what they specifically mean. So most of the time, rate law questions, they give you a graph, and there's multiple questions about that graph. Talking about the rate law of your chemical reaction, and that's going to be super important to answering all those questions. And then basically, just as a big overview, a rate law basically determines how quickly two reactants come together to form equilibrium with the products they create. Equilibrium is when equal reactants and equal products are being made at the same time, so they kind of like switch back and forth. Trick question they'll ask you is, what does equilibrium mean? And one of the answers might be, it means that reactants equal products. That is not correct. It means reactants are creating products at an equal rate that products are creating reactants. So that's just an easy answer to get on a test. Every teacher I've had that has taught this has asked that question. It's a great trick question chemistry teachers like to ask. So if you have a teacher who asks that, now you're going to get it right. And they're going to be like, how did you even get that right? But anyways, back to the problem. So we have this graph for the reaction between NO and O2. Basically, it wants to determine the order of the reaction for each reactant. And so the way that we would do that is we are going to divide different things to get us what we want. And so we need to figure out what the factor of multiplication is for NO and O2. So to do that, we find two values that are the same in one column. And that's going to cancel out whatever concentration that is. So in this case, it's going to cancel out NO. And then we're going to divide by everything else. And we're going to kind of solve like for in an X-like manner again. But this will make a lot more sense when we write it out. So basically, we're going to divide this whole section by this whole section. So dividing top by bottom, or actually we'll divide bottom by top so we get some nicer numbers that aren't really tiny. So I'm going to take that away. All right, so we have 0.01 NO over 0.01 NO plus 0.0102 over 0.0102. And then that equals the rate of reaction, which is, that should be a 0.02. It's talking too fast. 0.02. And then that's going to equal 5 times 10 to the negative fifth over 2.5 times 10 to the negative fifth. So this is all going to cancel out right here. 0.01 over 0.01 is 1. So it cancels out. This is going to have a factor of 2 O2 to a factor of 2 of the rate of reaction. So then we divide those factors, and since O2 is going to equal 2 over 2, O2 it just has an order of reaction of 1. So that's what this is asking, is what is that order of reaction? Now, knowing that, how would we find the order of O2? How would we find the order of NO? How would we find the order of NO? If the order of O2 is 1, because we did it this way, how would we find NO? You've got about 45 seconds. Start solving, trying to figure out what that order is going to be. And then in 45 seconds, I'll start working and we'll all come together. But see if you can beat me. All right, about 30 more seconds, guys. $15 more seconds. 3, 2, 1. Okay, so this is how I would solve it. I have 0.01 here and 0.01 here. So I'm going to use these two rows this time to solve my problem. Sorry, erase some of that. And so I would do 0.02 NO over 0.01 NO plus 0.0102, and that's because, again, this is going to cancel out my O2s, which is very important, equals 1 times 10 to the negative fourth over 2.5 times 10 to the negative 5. Then I'm going to put that in my calculator, and I'm going to get 2 NOs equals, I'll give y'all 20 seconds. Put this in your calculator. What is that value? See if you can beat me to solving it. What is 1 times 10 to the negative fourth divided by 2.5 times 10 to the negative fifth? All right, 5 more seconds, guys. Okay, it's basically saying the same thing as 10 divided by 2.5. So your answer right here should be 4. Then to solve for NO, again, we're just dividing by that coefficient, and we would get that the order of NO is 2. So, like our question asked, what's the order of reaction for each reactant? We have determined that the order of reaction for O2 is equal to 1, and the order of reaction for NO is equal to 2. If that makes sense, type yes or anything like that in the chat of wherever you're streaming from. If you're still confused on how we found that, I know there's a lot of math and something new we haven't really touched on before. If you're still confused, let me know. Type any questions you have, any homework questions, anything you need, type that in the chat and I would be more than happy to answer it for you. But now we're going to move on to the second part of our question. Write the rate equation. So we want to write the rate equation. What is the rate equation? So rate is basically equal to K and then your concentrations. So what we would do is we would write our rate is equal to, actually, I'm going to challenge y'all. What is this equation? If we were plugging in our concentrations in our orders, oh yeah, it's concentration to the order that there are. What would that equation be? You've got 45 seconds. What is our rate equation for this problem? I'll zoom out a little so that you'll have all that information you can draw on to figure out the rate equation. About 30 more seconds. "15 seconds, guys. You've got this. Let me know what you get as your answer." All right, 5 seconds, you guys. Type those answers in the chat box. All right, so our rate equation would be rate equals K of NO to the second order, which we determined right here, times the concentration of O2, which is just the first order. You can write that one in if you want to, but it's not needed. So this is the rate equation that the problem is asking for. It's also our rate law. Little challenge real quick. You've got 20 seconds to answer this question. I didn't write it down, but what is the order of the overall rate equation? It's a pretty easy one. 5 seconds. What is that order, guys? 3, 2, 1. If you said third order, you're absolutely correct. The way I got this is just by adding the orders of each reactant together. So 2 plus 1 equals 3. It's third order. All right, the last part of this problem is we want to figure out what is K. We have K was this variable, but we don't know what it is. So let's solve for that. Basically, we're going to pick for this problem one line. So I'll pick this second one. Looks nice and easy. One line, plug all those values in, and solve for K. So my rate for this problem is, I'll highlight it so we can all see it, 1.0 times 10 to the negative fourth equals K. K's our variable. That's what we're solving for. Times NO. So NO's right here, 0.02 squared times 0.01. Okay, y'all have 1 minute to solve for this problem, and then I will start solving and we will check our work. 1 minute. What is that answer? "30 seconds, guys. What is K? Can anyone figure out what K is? 15 seconds. 3, 2, 1. Okay, so the way that I would go about solving this is first, I would square my 0.02, so I would get 0.0004. Then I would multiply that by 0.01. So I get 1.0 times 10 to the negative fourth equals K times 0.000004. Then I would put that in my calculator. So I get 0.0001 divided by point. It's a lot of zeros in this problem. 0.00004 equals 25. So we have K equals 25. I just divided that on both sides. And I got K is equal to 25. If you got that, great job. We are doing so good tonight. This is your last chance to ask any questions that you have. We have about 6 minutes left in our live stream. So any lasting questions you have, type those in the chat, and I would be more than happy to answer them for you. While you're typing, we'll start working on this last problem that I have. I am going to change it a little because I think AGCL is a little bit too advanced for us. I think we can do some potassium acetate. So we're going to do KC2H3O2. That's what I've changed it to. I want us to convert 840 grams of potassium acetate to moles. So I'm going to give y'all 30 seconds. Find that molar mass of potassium acetate. You've got 30 seconds, guys. 15 seconds. What's that molar mass of potassium acetate? 5, 4, 3, 2, 1. Okay, so the way that I'd solve this is I divide it into how many of each there are. So I have 2 C's, 3 H's, 2 O's. My molar mass from the periodic table of K is 39.1. My molar mass from carbon is 12.01, and I multiply that by 2 because I have 2 moles of carbons, getting ahead of ourselves. The molar mass of hydrogen on the periodic table is 1.01, and there are 3 moles of that hydrogen. And then oxygen, we have 16 is the molar mass from the periodic table, and then we have 2 moles of that. I'm going to give y'all 30 seconds to do those multiplications across. I'm going to be writing them while you guys solve them. So if you beat me to solving any of them, let me know in the chat. So for the top one, I'd get 39.1. The bottom, 2 times 12.01 is 24.02. 3 times 1.01 hydrogens is 3.03. And then 2 times 16, 32 of oxygens. And now we just add them all together. So we've got about 30 seconds. Add those together, guys. Let me know what you get. 15 seconds. What did y'all get for that overall molar mass of potassium acetate? And in this chemical formula, the K is the potassium, and the C2H3O2 is the chemical formula for acetate. It's probably a polyatomic ion y'all will have to learn at some point. So now is a great time. C2H3O2 is acetate. All right. If you had 98.15 grams per mole as the overall molar mass of potassium acetate, you're absolutely correct. Great job, guys. And now we are going to actually solve the problem. We have all the things we need. Now we need to convert 840 grams of potassium acetate to moles. So I'm going to give y'all 1 minute. I think we're far enough in our chemistry knowledge that we can get this on our own. So 1 minute, how many moles can you make out of 840 grams of potassium acetate? "45 seconds, guys." All right, 30 seconds. "15 seconds." All right, so whatever I'm given is what I start with. So I'm given 840 grams. And then I want to go to moles. And so we've already calculated that molar mass. So I go from grams, Kc2H3O2, I put that on the bottom, and moles of Kc2H3O2 on the top. 1 mole is 98.15 grams, which is what I determined right here. And then I'm just going to divide that in my calculator. So I would put 840 divided by 98.15, and I would get 8.56 moles of Kc2H3O2. Don't forget to write your units and your chemical formulas. Some teachers will count off if you don't put that. So it's very important to put your units, like moles in this case, and the chemical formula, like potassium acetate. We are to the end of tonight's live stream, but it was so great having you guys. There is a QR code in the top left with all of the live office hour sessions check offers throughout the week. There's chemistry, organic chemistry, calculus, algebra. Anything you can think of that you might need help on is probably up there. There's also information on how to get more study help from Chegg. So I encourage you, click on that QR code. We will have more stoichiometry live office hours same time next week. So I encourage you to stream. We will be on YouTube streaming. So join from YouTube if you can. And I encourage you to join other live streams throughout the week. Thank you so much, guys. Hope to see you.